The third item on the agenda is the annual independent review of the long-term operation opinion. You may recall this used to be referred to as OCAP. LU, as it's now known, Long-Term Operation Opinions Annual Review, is conducted by the Science Programme to inform the Fish and Wildlife Service and the National Marine Fisheries Service on how well the past year water operations and regulatory actions that are required through the RPA, the Reasonable and Prudent Alternative Actions, how did they work? So this panel comes in, they take a look to see what were the outcomes from the past water year, what lessons can be learned and taken forward, what sort of new science should be incorporated by those agencies when they're making the decisions, and then, as necessary, to make scientifically justified adjustments to the RPAs to assist with real-time decision-making for the next coming water year. So this is an extremely important panel. And what the Fish and Wildlife Service and the National Marine Fisheries asked us to do this year is to focus specifically on two items. One is the spring 2012 operations. How did that work? And then also to focus on Clear Creek, which is one particular system looking at steelhead, the RPAs associated with that. So that panel will be convening somewhat appropriately on October the 31st and November the 1st for anyone who's interested, and we'll certainly be reporting back to you on the outcomes of that. The next item was just to give you an update where we are with the online journal, the San Francisco Estuary and Watershed Science. And I think what's particularly interesting about this current issue is, for the first time, the conceptual models which have been developed actually over the past decade to help guide restoration activities and the management of the delta have actually been published in the peer-review literature, and it's very appropriate that these have been compiled in a single journal, and it's our online journal. So it's taken a long time to get these through the peer review process. And it's worth spending just a few minutes on it, because at the town hall meeting that I'll talk about in a lot of detail in a few minutes, one of the concepts which Mr. Fiorini had pointed out was the need for the analysis tools and the models to actually see the direct actions of consequences, so you could follow the action of that decision through many layers, through the ecology, through many other things. And so that was a grand challenge, and Mr. Fiorini pointed out, we're a long way away from that, but these conceptual models are an initial attempt to describe very clearly what we understand from the qualitative perspective, where we have quantitative models that pick up part of these. And as Mr. Fiorini pointed out, this is a long, long way in the future to have a comprehensive modeling suite like that. But you can go to the online journal and look at these yourselves. And here I just picked a very simple, probably the most simple conceptual model. And this is put together by the USGS, Scott Wright and Dave Scholhammer in particular. And why the sediment river supply is so important, of course, there's many reasons, but the two really big drivers is, one, this sediment that comes down the rivers is one of the main sources for which we can build land and sustain wetlands under sea level rise in the future. So getting a good handle on the sediment availability, how much might be there to help support the restoration actions, is very important. It's also very important because of the link which is being better understood with each season that passes between turbidity, much of which the turbidity is the inorganic, the material coming down the rivers, and where the delta smelt hang out. So understanding the sediment supply, if that's going to be reduced in future years, that could have a very significant impact perhaps on the survivability of smelt. So this is the simple conceptual model, and actually I can't use a pointer, but you can see, so the pink box in the middle there is what is the outcome. And this is basically the river sediments. On the right-hand side, you can see the drivers that affect the sediment in the river. It's the geology, it's the landscape, it's the hydrology, and the climate that's moving the soil and the sediment off the hill slopes and into the river itself. On the left-hand side, you see all of the anthropogenic drivers or the human-induced influences that is affecting that availability of sediment. And so just to pick out one of the samples there, the old hydraulic mining. So you're probably aware that when hydraulic mining was occurring 100, 150 years ago, that was a very destructive practice. It put huge, massive volumes of sediment into the river systems that 25 years ago, Dr. Krohn at UC Davis pointed out that this was a slug of sediment moving through the system, and that was going to have a very major impact on the morphology and sediment in the delta. And his initial predictions have been certainly proved right and spawned a lot of more recent studies. But what's important here is to look at the various arrows, because these show the various connections. And I won't spend a lot of time on it, but this shows three things. It shows the connection, how various things are connected. So if you make one action, how it has an impact on other things within the system. And those arrows describe what we understand qualitatively. So if you've got a group of scientists together in the room and you ask for their opinion how something works, that describes the generic understanding of how things are connected. The box on the right there shows the quantitative understanding. So this is when we can actually put mathematics, we can build models, we can begin to be predictive, we can describe the past. How well do we actually understand that? And the third box tells us how important those connections are. So if something's not really important, that's not where we want to invest research dollars, because it's not going to affect the outcome. But if it's really important, then we need to know that. And whether the line is dotted or dashed or solid gives us an indication of our depth of understanding for those particular connections. So if you have a very thick line there, but it's dotted or dashed, it means that's very important, but we really don't understand much about it. So in these pictures, it's a way of capturing in these what can be extremely complex. So that's the simplest one in the first batch of papers which are being published. To show you how complicated it can get, you don't need to read this, but this is just part of the life stage of one particular fish species. And you can see all of the various connections and complexities there broken down by this, by knowledge. What does the consensus of the scientific community tell us about what we know about that particular life stage? So this is quite a remarkable achievement to get this understanding out there where people can comment, they can say we don't agree with that, and it will also help focus research. Shall I just go back here? Just some of the authors who put this together. Bruce de Janeiro, who's very familiar, he's helping guide some of the BDCP processes, and you can see there also a heavy representation from some of the staff in the Delta Science program, particularly Lauren Hastings, and some of the alumni of the Delta Science program. So that's the... Well, first of all, are there any questions on those conceptual models? The link is if you're interested and want to read up more about that. Particularly the first introductory paper is very easy to read. It's well written, and it describes why these conceptual models are being put together.